If you're running a business today, you're almost certainly using workflow automation. I mean, these tools, n8n, Zapier, whatever you use, they're the digital glue, right?
Absolutely. They connect everything.
Everything from your Google Ads to Salesforce, even your payments and Stripe, it's
Hmm.
it's just incredible convenience. But all that power in one place, that's a massive risk.
A huge risk.
So today we're doing a deep dive into that risk. We're focusing on a really sophisticated supply chain attack that hit a big open source platform, n8n.
Hmm.
Our mission is to unpack how attackers got into n8n's community ecosystem with a weaponized NPM package. But maybe more importantly, what this tells us about the security of your entire digital setup. Okay, let's get into it.
Yeah, and this isn't just another breach story. This is a serious escalation. It shows how attackers are thinking now.
How
They're
so?
not hitting the main platform head on. They're exploiting trust.
Developer trust in these little community add-ons that we all use to make these systems powerful.
And that really raises a critical question. How secure is this whole ecosystem of tools we depend on every single day?
The attack started with some clever deception, really targeted at a high-value entry point. The attackers built a malicious NPM package, and they disguised it as a Google Ads integration tool.
Of course, Google Ads,
Why, of course.
because it's a guaranteed bullseye. To manage ads, you need high-level credentials, and almost every business out there is running ads. It means the people installing this package definitely have valuable keys.
And the package name itself, I mean, this should have been a screaming red flag. The main one was called n8n nodes, HSGJF, R2N VCM, last token.
Exactly. I mean, it's just a random string of letters. That's not what a professional maintained package looks like.
Not at all.
But it tells you something about pressure developers are under. They're moving fast. They need a feature. They see Google Ads, and they install it. They don't look closely at the name.
So let's talk about the execution, because the trick was pretty slick. A developer installs this thinking they're getting a normal Google Ads node.
It shows up in their n8n interface, looks totally normal, and then it kicks off a classic credential theft operation.
Yeah, and it wasn't a brute force attack. It was social engineering, but baked right into the software.
So you click to set it up.
And it presents what looks like a completely authentic form, the usual place where you'd enter your API key or go through an OAuth flow.
Right.
So the developer types in their keys, hits save, and thinks, great, my Google Ads are connected.
But that's not what the code was doing, was it?
Not at all. In the background, while the workflow is running, the code was silently harvesting those credentials. The OAuth tokens, the API keys, all of it.
And then sending them where?
Straight to an external server controlled by the attacker. It's theft, but it's disguised as a completely normal configuration step. And because it's n8n, they didn't just get a Google Ads login. They potentially got the keys to the entire kingdom.
Right.
And that really brings us to the core of this. Why is compromising a single community node on a platform like n8n so incredibly valuable for an attacker? You're saying it's more than just one service's credentials.
Oh, much more. The thing is, a platform like n8n, it doesn't just run workflows. It acts as a centralized credential vault.
A vault. So it's holding all the keys to the kingdom in one place. When you say high stakes, what kind of keys are we talking about?
We're talking about API keys and OAuth tokens for everything.
Yeah.
The sources point to Google Ads, sure, but also Stripe for all your financial transactions.
Oh, wow.
And Salesforce for all your customer data. I mean, think about the motive there. An attacker gets one node, and suddenly they can potentially manage payments, steal customer lists, redirect ad spend.
It's an economy of scale for hacking.
Exactly. One breach, massive access.
Okay, so if it's a vault, why on earth are these community tools, these unvetted third-party packages, allowed such deep access? I'd assume they'd be sandboxed, kept separate from the main keys.
That is where this gets really interesting, and frankly, a bit alarming. The vulnerability is in the architectural trust model itself.
What do you mean?
Well, most platforms do use sandboxing. They isolate third-party code.
Like putting it in a little playpen where it can't touch anything dangerous?
Precisely. But in the n8n environment, these community nodes, they aren't properly sandboxed. They run with an exceptionally high level of trust.
How high?
They essentially get the same trust level as the core n8n platform itself. That's the staggering architectural flaw here.
Wait. So you're telling me the platform's design is the vulnerability. What does that high trust actually let the malicious code do?
It gets full operating system access.
Full OS access.
Yes, and this is a crucial point. It means the bad code can do way more than just run a workflow. Let's break that down.
Please.
First, it can read environment variables. This is where people often store really sensitive global secrets, database connection strings, other master keys, things that aren't even tied to that one node.
Okay, that bad.
Second, it gets file system access. So it can just browse around the server looking for config files, user data, cached credentials for other services running on that same machine.
So it can steal things that have nothing to do with n8n.
Potentially, yes.
Yeah.
And third, and this is what a sophisticated attacker would do, it allows for lateral movement, meaning the malicious node could use its OS access to install a backdoor, to set up persistence so it stays on your system even if you delete the node. It could even start probing your internal network.
Wow.
They're not just stealing keys anymore. They're establishing a permanent foothold inside your infrastructure.
That changes the entire risk calculation. When you install a community node, you're not just giving it access to Google Ads. You're basically giving unvetted code from the internet root access on your server.
You're handing it the keys to the front door, the back door, and the safe.
And what's really sobering here is that this wasn't just one bad package. The Endorlabs researchers who uncovered this, they found it was a coordinated campaign. They identified at least 8 different malicious NPM packages, all targeting the n8n ecosystem.
It was a targeted effort for sure.
Yeah.
And you can see how successful it was from the download numbers. That primary package we mentioned, the one with the crazy name,
Yeah.
it was getting over 3,400 weekly downloads before it was taken down.
3,400 a week. That's not just a few hobbyists. That suggests thousands of businesses, dev shops, even enterprises were installing this. That's a huge number of exposed environments.
It is. Thankfully, once it was found, the security community acted fast, the packages were pulled from the NPM registry, and public security advisories were issued. There's a specific one, GHSA 77G5 QPC3 by 24R, that lets people track and fix this specific issue.
Right.
But if you connect this to the bigger picture, this isn't a new strategy. It's almost a carbon copy of attacks we've seen against GitHub Actions workflows.
The same playbook.
Identical. The attackers go after the automation platforms because that's where the trust is. Developers implicitly trust the repositories, NPM, the GitHub marketplace, where they get their tools.
So the attackers are just following the money, or in this case, the data. As businesses move more of their core operations onto these automation platforms, the attackers just shift their focus to the weakest link.
And the weakest link is almost always our reliance on third-party code for speed and convenience.
Okay, so we've covered the attack, the scale, the architectural vulnerability. Now, for the most important part, for you, the listener, what does this all mean for how you use these tools? We need to turn this into some concrete, actionable advice.
Absolutely. The researchers laid out 4 critical points. The first is about trust. You have to prioritize the official n8n nodes, the ones made by the core developers, over any community alternatives.
That seems like a no-brainer. Stick with the official vetted stuff.
It is. That code is maintained, patched, and has the highest level of assurance you can get.
But what if a community node does something unique that you just have to have?
Then you move to the second point.
Right.
Due diligence. You have to audit the package before you install it.
And what does that actually look like, beyond just checking the name?
You have to be skeptical. Look at the maintainer's history on NPM. Is it a brand new account? Does the package have very few downloads but claims to integrate with a huge service like Salesforce? That's suspicious.
Okay.
And if you can, look at the source code. You don't have to be a genius, just look for weird things like network requests going to strange URLs or code that's trying to access the file system when it shouldn't need to.
The third safeguard is about monitoring. This is more technical, but it's essential. You should be monitoring the outbound network traffic from your n8n server.
Yes. You know your n8n instance is supposed to be talking to, right? The Google API, the Stripe API. A compromised node isn't going to send data there.
It'll send it somewhere else.
To a random IP address in another country, probably over an unusual port. If you set up alerts for any unexpected external connections from that server, you can catch this kind of thing.
And finally, the principle of least privilege. Everyone talks about it, but it seems hard to do with automation tools. How does that help here?
It's a blast radius minimizer. It's maybe the most effective thing you can do.
Give me an example.
Okay, let's take Stripe. A lot of people, for convenience, will set up their Stripe node using an account that has full admin access to everything.
Right.
If that mode is compromised, the attacker gets everything. They can change bank details, issue refunds, create new admin users. Instead, you should create a brand new isolated service account just for that n8n integration.
And give it minimal permissions.
The absolute bare minimum. Maybe it can process payments, but it can't see historical financial data or change account settings. That way, if the credentials get stolen, the attacker's access is contained. They can do very little damage.
That makes perfect sense. It contains the damage.
So to synthesize the core conflict here, workflow automation is becoming more and more central to how business is run. It's all about efficiency and speed.
Mm-hmm.
But organizations now have to consciously balance that convenience against the massive security risk that comes from blindly trusting all the community-provided pieces that make it work.
It's the ultimate paradox, isn't it? We're told to move fast, but the tools that let us move fast come with this hidden cost. Given that the architecture of a platform like n8n lets any community node run with full OS access, I mean, what's the real trade-off you're making? Is that speed and convenience worth granting root-level trust to a piece of unvetted code, especially when your financial and customer data is on the line? We would strongly encourage you right now to go audit your own installed packages. Check those access logs immediately.